Just want to remind people that you do have to have all your homework in before you take a quiz. So some of you are going to have 2 or 3 assignments to show me tomorrow morning. Make sure you get in a little early and start showing them to me before class begins, because I don't want to spend a lot of time and take people's quiz time away. Although the quiz itself is not very long. It's pretty much just 1 page front and back. It's not an exceptionally difficult quiz if you have a decent idea of what's going on. It's not exceptionally long. Pretty straightforward, actually. And the review today covers it quite well as far as what you can expect to see on the quiz. So I think you'll find that helpful. But hold on. Martha, first let's just go over the homework and see if there are any questions on that. I think there probably are. We did what? 2 through 10 even, and then 11 through 14, I believe. So 2 was y equals 6 sine 2 pi t minus 1/4. 4 was 8 sine pi t minus 1/2. 6 is 8 sine 4 pi t minus 1/8. 8 is y equals 16 sine pi over 2 times t minus 1. And 10 is 16 sine 8 pi t minus 1/16. 11, we had y equals sine 528 pi t. For 12, y equals sine 440 pi t. For 13, y equals 3.2 sine pi over 6.2 t, and if they start at the bottom, you do t plus 3.1. And the pendulum problem, y equals 5 sine pi t, and that you could just leave it at t if you figured it started at the center of the cycle, which is fine. But I think the book started it actually on the far left. They started on one side, so they did t plus 1/2, which is fine as well. Either one works. Yes,
Can we go through number 13?
13. Although Tides and Fishbin is not as famous as those in the Bay of Fundy. Yay. These are all very common places that we go all the time. Fishbin and the Bay of Fundy. A high tide of 3.2 meters is quite impressive. Yeah, it's like 10 feet for a tide differential. That's pretty impressive. So if the tides occur every 12.4 hours in Fishbin, what's an equation for the tide? All right, so we know that, again, we have our amplitude and our period. Amplitude is 3.2 meters. The period is 12.4 hours. That's what we're given. B, so when we set up our period is also 2 pi over B. So B equals 2 pi over the period, which in this case is 2 pi over 12.4, which would be pi over 6.2. If you left it as 2 pi over 12.4, I probably wouldn't get too excited, just because, well, I mean, there's already a decimal in there, so what's the difference if there's 2 pi over 12.4 or pi over 6.2? Once we have that, then our equation comes out pretty easy. It's 3.2, because that's the amplitude. Y equals 3.2 sine of pi over 6.2 x. Now, here's where it gets kind of open to interpretation. If we just start at a 0 point, if we start this, so it graphs at 0 and then high tide, low tide, high tide, low tide, then we can just leave it like that. But if for some reason we want to start at high tide or low tide, then we do have to do a phase shift of 1/4 period to start at a high tide or low tide. And that 1/4 period would be 1/4 of 12.4 is 3.1, so it would be x plus or minus 3.1 depending if you want to start at high or low tide. But really for the way I'm going to set it up and the way we're going to set it up in the test, I'm not going to probably make you do the starting at high tide or low tide. We could probably start right at the center. So this is really all I'd be looking for, is this equation right here. All right? So I'm not going to worry necessarily about starting at high tide or low tide. If we displace a spring, we have to start at the bottom of the pull of the spring. Yeah, then we do have to do that minus 1/4 period deal. That starts us at the bottom. Yes?
Can you show how we would do that?
Sure. If we had to do that, if we did want to start, say, at low tide, we wanted to start our curve at low tide here, and then up and down and that. You want to start at the low tide spot. We'd have to do, the only thing that would be different, and then we'd take, what is our period? Our period is 12.4 hours, right? We'd divide that by 4. Because we want 1/4 of the period. That's our phase shift. We're phase shifting 1/4 of a period to get from 0, which was 0 here, down to here. That's 1/4 of the period. So 1/4 of 12.4 is 3.1, so it would be minus 3.1.
Do you always do a quarter?
To start at the bottom, yes.
Okay.
Minus 1/4 to start at the bottom, plus 1/4 to start at the top. Okay? And it's always 1/4 period. 1/4 of whatever the period is for this function. All right? That's kind of fun, isn't it? But that, again, if we start with pulling a spring, we have to start with that because we have to start at the bottom. A spring is going to start in the center. It's going to have to start at the bottom to oscillate. But tides, we could start at 0. So you don't have to do that. Other ones you'd like me to go over? Yes.
You go over one like the top one?
Sure.
Number 4.
Sure. Q is 8 centimeters. That's the displacement, initial displacement. And R is R cycles every second. So it takes 1/2 cycle every second. A little different here. Just a way to do it. Q, what they give us here is also what we call A, amplitude, which is 8 centimeters, which is easy. Okay. R is 1/2 of a cycle per second. But that's not period. That's frequency. That's a reciprocal of period. I want to know how many seconds per cycle. That's period. So I do the reciprocal. So that's 2 seconds for 1 cycle. So my period is 2 seconds. Once I know the period is 2 seconds, I know that B is 2 pi over the period, or 2 pi over 2, or just pi. And C, my phase shift, is 1/4 of the period, which is 1/4 of 2 seconds, which is 1/2. So it's Y equals 8 sine B parentheses X minus C. Phase shift, 1/4 of the period. 1/4 of 2 is 1/2. What was the period? Period's 2 seconds. What's 1/4 of 2 seconds? Half. Okay, that's where it comes from. And to start at the bottom of the curve. Because remember, normally my sine curve starts at 0 and goes like this. And it also comes back here and does this thing, right? What we want to do, if this is 0, all right, there's my axis. I want to start it, instead of starting at 0, I want to start at -1. I want to start at the bottom of the pole. That's my phase shift, because that's 1/4 of the period. To get from the bottom to 0 is 1/4. Get from 0 to the top is 1/4. From here to here is 1/4. Here to here is 1/4. Here's 1/4 of the period. Yes. 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 So one cycle takes how long? Half a second. Remember, they're giving us cycles per second, which is frequency. We want period, which is a reciprocal of frequency. That makes the period half a second. So 2 pi over 1/2 would be 4 pi. And then 1/4 of 1/2 will be 1/8. I'm doing number 4. I'm doing number 4, not number 6. Yep. Okay, that's an interesting noise, but okay. Yeah, for number 6 it would be 8 sine 4 pi, and then t minus 1/8, because the period is reciprocal of the frequency. I know it seems a little bit out there, but believe me, once you get into this in physics, you will be so grateful that you've seen this once before, because you go, oh, that's easy. And you'll be sailing through the physics, even if you struggle a little bit now. But again, this is not the major focus of tomorrow's quiz. Okay? One question on the quiz tomorrow deals with simple harmonic motion. One question. The rest of it deals with tangent, cotangent, secant, and cosecant. And that's where we want to spend our time focused, because we need to know those 4 functions. So before we do anything else, let's do some sketches of the basic functions. Okay? In fact, I'm not going to do graphs. I'm just going to do sketches of the basic functions. Okay? Y equals tan x. Again, we're at the no graphing calculators portion of our course right now. So you're not going to have a graphing calculator graph these functions for you. You need to know the basic graphs for y equals tan x. Where does it start? At 0. What do we know about tan x? Tangent of 0 is... Oh, come on. This is one that you should know like that. Okay? This should be an automatic. I should be able to say sine, cosine, tangent, cotangent, secant, cosecant, cosecant of 0, and those are facts you should know just like that. Okay? You got to have that starting point fact in your brain. Absolutely have to know that. Tangent of 0 is 0. If you have those starting points, you can always figure out the rest, but you can't do a thing if you don't know the starting points. Tangent of 0 is 0. It is not an asymptote at 0. It is a 0 at 0. And what do we know about tangent? It goes which direction? Up to the right or up to the left? Up to the right. It's a positive slope, essentially. Okay? And where are those asymptotes going to be for tangent, then? Half a period either way, which is normal period is pi, so half a period would be pi over 2. And negative pi over 2. And so where is it 0 again? 3 pi over 2 is going to, every pi over 2 thing is where it's going to be, have an asymptote, so this is going to be a pi right here. Okay? And there's our basic tangent graph. The other critical point that we don't really worry about so much, but is there, is the pi over 4 and 1. That's the other critical point with y equals tangent x. So you have to know your basic tangent graph. You have to know your basic cotangent graph. What's the value of cotangent of 0? Undefined. We have an asymptote. And we have another asymptote over here where? Pi. And another one at 2 pi. So the in-betweens are the pi over 2's. Notice, where tangent is 0, cotangent is undefined. They're reciprocal functions, right? Where tangent is undefined, cotangent is 0. It makes sense. That should be 3 pi over 2. And they're all positive in quadrant 1, so cotangent goes up to the left. You need to know and be able to recreate those basic graphs. And really it just comes down to rote memorization, or at least memorization of a couple basic facts so you can create the graphs every time. Let's look at secant and cosecant, just the basic graphs. Nothing fancy. And again, we're just sketching. Let's start with y equals secant x. Secant is the reciprocal of which graph? Cosine. So I'm going to start by doing my cosine graph just dashed in. Okay? Where this is 2 pi, pi, pi over 2, 3 pi over 2. Now that I know that, I know where to put my asymptotes. Where cosine is 0, and my u's just come and kiss the cosine graph, because they're reciprocals, they're friends. They give that little kiss of friendship at the top and the bottom. And then we don't need my little red dotted line in there anymore. We can just get rid of that. And that's my cosecant, or my secant graph. Cosecant similar, except cosecant is a reciprocal of sine. So again, we can start by sketching in my sine function just as a dashed line. Asymptotes where sine is 0, which is 0, pi, and 2 pi. And it just comes and kisses the graph there. We can get rid of that. There's my y equals cosecant x. So again, I really don't memorize the cosecant and secant graphs. I memorize the sine and the cosine graphs. I never directly graph secant and cosecant. I always graph sine or cosine first, and then my secant or cosecant in there. Not enough caffeine this morning. The Tuesday after homecoming week, I think, is worse than the Monday in some ways, you know? Monday, you still got a little bit of adrenaline going. Tuesday, it's just gone. So knowing those 4 basic graphs obviously going to be important. And the 4 basic graphs that we need to know are sine, cosine, tangent, and cotangent, not secant and cosecant. Secant and cosecant we get from sine and cosine. So if you're still struggling with that sine and cosine graph, you need to make sure you're getting in here, getting some extra help, doing what it takes to get that sine and cosine graph down, because it's important. So those are the basic graphs. One more time. Let's look at how we can manipulate them, because that's really what this is about. Okay. Identify period, phase shift, vertical shift of each function. okay? Period, phase shift, and vertical shift. Amplitude I left off here for now just because a lot of the tangent and cotangents, it's not really amplitude, it's stretch and shrink. We aren't going to sweat that too much. Y equals cotangent 3x minus pi over 4. What would the period be of this particular function? For sine, cosine, secant, and cosecant, the period is 2 pi over b, right? For tangent and cotangent, it is pi over b, because the period for tangent and cotangent, the standard period for tangent and cotangent is just pi. Unlike the other four functions where it's 2 pi. So period is pi over b, which in this case would be pi over 3. The phase shift is what? Positive pi over 4, opposite of what's in the parentheses, and the vertical shift is 0. There is no vertical shift. Because you'd have to have something out here, that would be my vertical shift. How about here? Cosecant. Cosecant. What is the period? Okay, it's 2 pi over b. b is 2, so that's 2 pi over 2, so that's pi. The phase shift is none. There is no phase shift because there's nothing in the parentheses with the x there. The vertical shift is down 8. Now, what if I had done that instead? Oh dear, now we have a phase shift, and now we have to think about that a little differently. If I do this instead, I have to factor out the 2, because I need that, so it's cosecant 2, x minus 4. And now we still have a period, but now I have a phase shift of 4 and vertical shift of 0. So parentheses or no parentheses makes a big difference there. In parentheses, that a minus 8 represents a phase shift. Outside parentheses, that minus 8 represents a vertical shift. It's a very subtle difference. Okay, it is not obvious. I don't think it's obvious at all. Just the presence of those parentheses, though, change the context of everything. So you got to be careful with that. Just a little bit careful. Again, we have to, if there are parentheses here, what's in the parentheses represents the phase shift, not the vertical shift, but the coefficient of x has to be 1, so I have to factor it out to make sure that's a 1. What's some of our examples there? All right. This is a good example of that. I've got a coefficient on my x. I'm going to have to factor, aren't I, before I can determine things. So tangent of 3, I got to factor out that 3. X minus what? 2 pi over 3 plus 1. And if you're not sure, redistribute it and check to make sure you got what you started with. Okay? If you're not sure about that factoring, say, what if I distribute this back? I get 3x minus 6 pi over 3, which is 2 pi. Yep, I did factor that correctly. We're not used to factoring out to get a fraction. That's not something we normally do, but we do here. So my period would be pi over 3. My phase shift would be plus 2 pi over 3. Always the opposite sign of what's in the parentheses. And the vertical shift is plus 1. I'm not asking you to graph these. I'm just identifying the parts. And you're going to get a lot of this on the quiz tomorrow, where you're not asked to graph it. You're just asked to identify what's going on with the function. And honestly, the single largest mistake people make on this is you notice we're switching between tangents and cosecants and stuff like that, is they forget to adjust the period. Oh gosh, is it a tangent? Is my period normally pi or 2 pi for this function? People get either fixated on one or the other values for period, and they do it all the way through and they get half their periods wrong. Because they forget they have to switch depending on which function is being used. What your normal period is it 2 pi over b or pi over b? So always kind of think about, when you're doing period, stop yourself and think twice. Whenever you're setting up your period, stop and go, wait, which function is this? This one is secant. Okay, so the normal period for secant is 2 pi. So I got to go 2 pi over b for this one. Slow yourself down and just go through that little thought process, and it'll be fine. Don't make that mistake on the quiz tomorrow. All right? I've already made that mistake for you. So now you don't have to do it yourself. Because we say we learn more from our mistakes than our successes sometimes. So there, I've made that one for you, so you don't have to. I'm trying to help you out there. Okay, so my period here, okay, secant, no, it's 2 pi over b. Aha. I even wrote it down so I know. Oh, and b is 2, so that's 2 pi over 2, so that's going to just be pi. By the way, I've got an amplitude here. My amplitude is 3. Yay. Fun. What's my phase shift going to be? Negative pi over 6. And my vertical shift? None. There is no vertical shift. Yes?
If we have, like, no number in the period spot, do you put a 1 or do you put...
That's 2 pi over 1, yeah. Like if this is just...
Oh, so you always get...
Yeah, it's like, say, y equals cotangent of x minus pi over 4 plus 2. Let's look at that one for a second. So no number there. So period is pi over b, which is just pi. Pi over, because b is 1. Right? Okay. And then I'd have a phase shift of positive pi over 4 and a vertical shift of plus 2. Right? So if there's no number here, we just assume b is 1. We have a normal period. Anything else? Good question. Obviously, then we're going to be asked to sketch some stuff. Now, on the quiz, what I'm going to have you do is I'm going to have you sketch it on the quiz, and then take a piece of graph paper. We're actually going to use the graph paper. Take a piece of graph paper and actually graph it onto the graph paper. So you'll do a sketch on the quiz. So I'm actually going to, this time, require you to do the sketch on the quiz. Because last time people didn't want to sketch it. They just wanted to go straight to the graph. They wanted to skip the sketch step a lot of times. So you will have to do a sketch of it on the quiz and then transfer that sketch over to the graph paper so we get a formal picture of it. So 3 secant 2 x plus pi over 6. So identify our parts. My amplitude is 3. We just did this one. This is our last example. My period is 2 pi over b, because it's secant. So that's 2 pi over 2, which is pi. My phase shift was negative pi over 6, and I had no vertical shift. So, to do my sketch, for secant, I'm going to start with which function? Cosine. My period is, my amplitude is 3. My period is pi. So this would be pi over 2. This would be pi over 4. This would be 3 pi over 4. My phase shift is negative pi over 6. This is always a tricky piece. Phase shift is with the x-axis, so I have to subtract 1/6 from each of these values. Now remember, back in the very first week of pre-calc, we did our twelfths. 1/12, 2/12, 3/12. We talked about putting everything in terms of twelfths. And that thinking is going to benefit us here, because I can think of this as minus 2 pi over 12. This is 12 pi over 12. So like 10 pi over 12, this becomes 5 pi over 6. 3 pi over 4 is 9 pi over 12. Right? Pi over 6 is negative 2 pi over 12. 9 minus 2 is 7 pi over 12. Pi over 2 is 6 pi over 12. 6 pi over 12 minus pi over 6 is 6 pi minus 4 pi, or 2 pi is 4 pi over 12, or pi over 3. Pi over 4 is 3 pi over 12 minus 2 pi over 12 is 1 pi over 12. And 0 minus pi over 6 is negative pi over 6. So we got some tricky subtraction going on there. We have to be comfortable subtracting with fractions. That's just something we got to do. Now we've got that. I know where my asymptotes are going to be. My asymptotes are going to be where there are zeros, so that's pi over 12. Put that on my sketch. We have another asymptote at 7 pi over 12, which is 6 pi over 12, or just a little bit more than that. So I now know that it's every that many units. There's another asymptote. It's 1, 2, 3 full blocks over. So 1, 2, 3 full blocks over. There's another one. There are my asymptotes. My max and mins are at 3 at the halfway point. So like pi over 3 is a negative 1. Pi over 3 is right there, and negative 3. So here it's going to alternate. That's going to be a positive 3 at the halfway point. Oh, I hate that. And this one is going to be another negative 3 at the halfway point. I just said okay. There we go. Thank you. All right. So there's my function. And I don't have to sketch necessarily the secant function up here. Just the cosine one is enough to get me to the graph. That's a hard one, though. Yes?
So why did you decide to go down on the system?
Why? Well, again, because this is a minimum point for my cosine function at pi over 3, right? So that point, that minimum, is going to be the same as this maximum point here. They always come up and just kind of kiss each other.
Will secant always go down first?
Secant goes down where cosine is down. Secant is up where cosine is up. So it doesn't always go down first. It just happened on this sketch that that's the first point I came to easily. I could have also gone to this point, negative pi over 6, 3, which is right there, and gone up as well. It doesn't have to go down first or up first. It just depends on the point I'm picking from the cosine graph. And so there's that graph of that function, a sketch and a graph. But again, that finding those points for those asymptotes and stuff like that, that was kind of tricky. We had to go to 12ths to do it. You had to be confident working with pi over 12 units. Let's look at a tangent one. Y equals tangent 2x minus pi over 4 plus 1. Again, we'll do a sketch first. And then this tangent function, I know goes through 0, 0. Then an asymptote. Okay, then an asymptote. That's basically my tangent function right there. I can just see what's going on with this. My amplitude is 1. My period is, this is tangent, so it's going to be what over b? Pi over b. b is 2, so my period is pi over 2. Which means that these asymptotes are where? Pi over, no, it wouldn't be pi over 2. This isn't a full period. This is a half period to here, right? What's half of pi over 2? Pi over 4. And negative pi over 4. And that's 0. And this would be pi over 2, because that's one period from here to here, isn't it? Okay? So this would be 3 pi over 4. I have a phase shift, though. My phase shift is how much? Plus pi over 4. So now I have to take all these x horizontal axis numbers and add pi over 4 to it. So this negative pi over 4 becomes 0. This becomes pi over 4. This becomes pi over 2. Now we're adding quarters, so it's a little easier. 3 pi over 4. And that becomes pi. And we have a vertical shift. How much is our vertical shift? Is how much? 1. All right, so this becomes 1. So my asymptotes are now at 0, pi over 4. I'm sorry, that should be pi over 2. I miswrote that. And at pi, instead of crossing at pi over 4, 0, we're at pi over 4, 1 now, and 3 pi over 4, 1, so my function looks something like this. Still going up and to the right, and that's my graph. Narrower, shifted right and up. But take one element at a time. Don't try to do it all at once. One last one quickly. Should be pretty quick. A pendulum displaces 9 inches from center each way on its oscillation if one cycle takes 1.75 seconds. Period. Write an equation to describe its motion. You may assume starting from the rest or 0 position, so no phase shift. Y equals displacement is amplitude 9 sine 2 pi over period x. Done. Couldn't be easier. Because I gave you the period, I took one cycle as 1.75 seconds. I could have also said, if I give you the frequency, then you have to do the reciprocal of the frequency under 2 pi. All right? There's our function. That's the extent of the simple harmonic motion on this quiz. One question like that. Where do you need to spend your time focusing? Tangent, cotangent, secant, cosecant. And we got there.